Well, hello there, ladies and gentlemen, wonderful young people. Here's what we're going to do in this video. We're going to talk about some pitfalls that exist within the quadratic formula, just a couple little things, and we're going to see the discriminant. Discriminant, man, it's awesome. Here's what we're going to be doing, right? So we're going to talk about pitfalls in the quadratic formula and the discriminant, which is going to tell you how many x-intercepts that there are. It is the best. Come on, listen to him. It's the best. Okay. Anyway. Here's a quadratic equation, ax squared plus bx plus c. The reason I know it's quadratic is because it has a degree of 2. The biggest exponent is 2. Quadratic equations, they have either 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. Now, in all three of these cases, the parabolas are going up, which means a is positive, but going down doesn't matter. They have 2, 1, or 0 x-intercepts, right? Now, any quadratic equation can be solved using the quadratic formula. And by solving, what we're doing is we're actually finding the x-intercepts. We're setting it equal to 0 and solving it, and when the output is 0 and y is 0, and we solve for x, we have found x-intercepts, okay? So, quadratic formula can be used to find the x-intercepts, and that means that when you use this formula, you will either have 2 answers, 1 answer, or none, right? Okay, let's get to it. Let's see an example. Here's what we got. 3x squared minus 2x minus 8 equals 0. First thing that people mess up is they forget to identify what a, b, and c are correctly, including the signs. So be careful with those signs. Plug it in correct. Now, I'm assuming in this video that you are already fairly familiar with the quadratic formula. If you're not, I'll put a link in the description. You can get caught up. But I assume you have already done this before, but you might be making a few mistakes. So make sure your signs are correct. Okay, now we have to be careful with our signs. This one everybody messes up. This is a negative 4 times 3. That makes negative 12. Negative 12 times negative 8. Positive 96. Negative squared is positive. This number right here will always be positive. There we go. Negative of negative 2 is positive 2. Now the next thing people mess up is they add this together and they want to divide that by 6. But the order of operations says that you have to calculate this numerator first and then divide by 6. And it's tricky because there are 2 calculations. There's a plus and a minus because there are 2 answers to the question, what times itself is 100? Square root of 100, you could read it that way. What times itself is 100? So 10 and negative 10. So you need to set up your 2 equations. Even if you're using a calculator, you need to write this on paper. 2 plus 10 divided by 6. And then 2 minus 10 divided by 6. So 2 plus 10 is 12. 12 divided by 6 is 2. 2 minus 10 is negative 8. And negative 8 divided by 6 reduces to negative 4/3 or negative 1.3 repeating, right? And the reason in this situation we have 2 answers. That means we have 2 x-intercepts. The reason we have 2 x-intercepts is because this radicand right here is a positive number. All right, now here's the deal. If that square root is the square root of a positive number, if that radicand is positive, you're going to have 2 x-intercepts always and forever. Amen. All right, let's see the next example right here. So we got x squared plus 10x plus 25. We're going to plug all our numbers in. I'm assuming at this point you are rock solid there. You're aware of the mistakes you could make. 100 minus 100 is, of course, 0. And the square root of 0 is 0. So this one has exactly one answer, negative 5. So here's the deal. If the radicand simplifies, if this thing right here simplifies to 0, the square root of 0 is 0, so that's just going to be one answer. Man. All right, let's see. One more example. 5x squared plus 6x plus 5. Man, those of you following along at home, I'm sure you can anticipate this is going to have 0 x-intercepts. Let's see why. Plugging all the numbers in, here's what we have. We have 36 minus 100, right? That's negative 64. Square root of a negative is imaginary. Square root of 64 is 8. So this is plus or minus 8i. Once again, write it all out. Plus and a minus, right? It's negative 6 plus 8i divided by 10. Now, you need to write this. Like if you're graphing, you can stop right here and you can say, oh, I don't have any x-intercepts. But just to make sure, if you were being asked to solve this equation, well, you would have to write this as a complex number, which is the real part, plus or minus the imaginary part, right? So you're going to have to separate this into 6 over 10 plus 8 over 10. So negative 6 over 10 plus 8 over 10. And then those can both be reduced to negative 3/5 and 4/5 I. Same thing for the negative. You're going to separate it into negative 6/10 minus 8/10 over I, 8/10 over I, and reduce them, and boom, you're done. So here's the deal. If that radicand, that's the number inside the square root, is negative, you're going to end up with imaginary solutions. So here's our three situations. We have a radicand, a square root of a positive number, a square root of 0, or a square root of a negative number. Do you see? So if the square root is positive, you're going to have two solutions. If the square root is 0, right? If the radicand is positive, two solutions. If the radicand is 0, one. If the radicand, the number inside the square root, is negative. So if this, which comes from inside the square root, you see? If this, which comes from inside the square root, is positive, you have two solutions. If it's 0, you have one solution. And if it's negative, you have no real solutions, but you have two imaginary solutions. That right there, boys and girls, b squared minus 4ac, that is the discriminant. Right? And so we can see from each of our examples how the discriminant could save us some time. So here we have 3x squared minus 2x minus 8. And let's see if we could just figure out how many solutions we have, right? Well, this is 100. Square root of 100 is that's a positive number, so there are going to be two answers. Remember, we saw this, we did this together a minute ago. We found out there was 2 and negative 4/3. Positive right here. More than 0, right? That's 100. Whereas this one right here, when we did that, it was equal to 0. So there's our situation. Whereas here, we had a negative radicand, and that would mean we're going to have two imaginary solutions, all right? So this is the deal right here. You should get a tattoo of this. You can do this in your head really, really easy. You don't actually have to do all of the work. Watch, check this out. Let's use the discriminant to determine how many x-intercepts this is going to have. So there's the discriminant, b squared minus 4ac, and this is our rule. If it's positive, the discriminant's positive, it's going to be the square root of a positive number. Has two answers. If it's 0, one answer. If it's two real answers, one real answer, or if it's negative, if this is negative, then we're not going to have any real answers. We're going to have two imaginary answers, which are going to be 0 x-intercepts, okay? So b squared minus 4ac. So that would be 4 minus 4, right? And then times a, which is 3, and times c is negative 11. So this is b squared, negative 2 squared is 4, minus 4, that's part of the formula, right? Times a, which is 3, times c, which is negative 11. So look at this. Here's what we've got. Look at this part right here. That's a negative times a negative. That's a positive number. This is 4 plus something. I don't even care what it is. It's 132, I think, right? 12 times 11? 132. But it doesn't even matter. All you need to know is if it's positive or negative or 0, right? So here, a negative times a negative is positive. So this will have two real solutions. This will have two x-intercepts. So hope this has been helpful. I hope we covered how you can use the discriminant, b squared minus 4ac. Hope you understand where it comes from and that this topic will be easily accessible, that you'll have sunshiny days. Oh, man. Puppy dogs all around you, unless you're allergic. Anyway, hope it went well, and good luck, guys.